Hello everyone. In this video, we are going to discuss the sixth problem which came in BStat BMath 2019. So here is the problem. You have been given that an is equals to root over of 2 minus root 2 plus and so on, where there are n many radicals, and the first part tells you to prove that is equals to 2 sine pi by 2 to the power n plus 1, and the second part tells you to evaluate the limit n tends to infinity to the power n an. So it really looks difficult, but let's see how we can solve it. So here is the problem. Now the idea is to go through induction because we have some formula which depends on n, which we need to prove. So first we are going to prove that 2 plus root 2 plus dot, where you have n many radicals, is equals to 2 cos pi by 2 to the power n plus 1, where n is greater than equals to 1. Now we induct on n. So first we see that for n equals to 1, 2 cos pi by 4 is nothing but equals to root 2. And you see that for n equals to 1, the relation holds true. So let it hold true for n minus 1 many radicals. Then what you have is 2 plus root 2 plus dot plus root 2, where there are n minus 1 many radicals, that is equals to 2 cos pi by 2 to the power n. Now therefore for n many radicals, let's see what happens. 2 plus root 2 plus dot plus root 2. Now here we have n many radicals, and this is equals to, now we are applying our induction here. So this, since this was true for n minus 1, so we are replacing that part by 2 cos pi by 2 to the power n. And now this, you can write it as 2 cos square pi by 2 to the power n plus 1 minus 2 sine square pi by 2 to the power n plus 1, and which is nothing but equals to root over of 4 cos square pi by 2 to the power n plus 1, and this is equals to 2 cos pi by 2 to the power n plus 1. So we have proved what we claimed. Now 2 sine pi by 2 to the power n plus 1 is nothing but root over of 4 minus 4 cos square pi by 2 to the power n plus 1, and this is nothing but 4 minus, now we are replacing that part by the formula that we have just proved, and we have squared it and replacing this part, and this becomes nothing but what we needed to prove, 2 minus 2 plus dot plus root 2, and this holds true for n greater than equals to 2. Now for part B, which was a very easy one, limit n tends to infinity 2 to the power n an is nothing but limit n tends to infinity 2 to the power n plus 1 sine pi by 2 to the power n plus 1. So we just need to take a pi and divide it by another pi. So this becomes sine pi by n plus 1 by pi by 2 to the power n plus 1. And you know that this limit x tends to 0. This is nothing but sine x by x, and that goes to 1, and you will finally get this to be pi.